Dear students, in this video I am going to explain what is coordinate covalent bond. A special type of covalent bond is formed in which the shared pair of electrons is contributed by one atom only. The atom which contributes electron pair for sharing is called the donor, and the atom which accepts the pair of electrons is called the acceptor. The bond between two such atoms is called coordinate covalent bond or dative bond or donor acceptor bond. It is denoted by arrow mark. Let me explain this coordinate covalent bond with simple diagram. In this diagram we have an atom. It is an atom. It has lone pair, so we called A is a donor atom with a lone pair, and B, the Lewis structure of B, you can see only 6 electrons. That means 3 pairs of electrons in the outermost shell. So boron needs 2 electrons, B needs 2 electrons to get noble gas structure, octet structure. So therefore B is called acceptor atom, being short of 2 electrons. When A and B approach each other, only A donates lone pair for bonding. Then that lone pair, that pair of electrons is shared between A and B. So here A only donates electrons, then A and B shared equally that pair of electrons. So A is donator and B is acceptor. In covalent bond, both atoms donates equally and shared equally. But in coordinate covalent bond, only one atom donates electrons, and the donated electrons are shared by the 2 atoms. That is very important. Here coordinate covalent bond is denoted by an arrow mark. And one more important thing, in Lewis dot structure we always shows the dots of outermost electrons. Okay. Now here the one more example for a better understanding, formation of H3O plus ion. At the beginning of the diagram we have H2O. H2O structure is angular, we know that. So oxygen is the central atom. At oxygen we have 2 lone pairs. So in hydrogen plus, that means proton, H plus ion. H plus ion doesn't have any electrons, so it needs 2 electrons to get stability. When water and H plus ions approach together, then one pair of electrons are donated by the water molecule. So H plus doesn't donate any electrons, only H2O molecule donates electron for bonding, and that pair of electrons is shared between H2O and H plus ion. Therefore H3O plus ion is formed. So you can see the coordinate covalent bond in H3O plus ion. Here H2O is donor and H plus ion is acceptor. Let me explain with another example. Here coordinate covalent bond present in ammoniate ion. Here nitrogen has in ammonia nitrogen is a central atom. At central atom one lone pair. What is meant by lone pair? Lone pair means even though these 2 electrons in outermost shell, they do not participate in bonding. So that kind of pair of electrons in outermost shell we call lone pair. So with these lone pairs, nitrogen in ammonia has octet structure. So H plus ion. H plus ion, hydrogen has 1 electron, but H plus ion doesn't have any electrons. So therefore H plus ion needs 2 electrons to get stability. Therefore between ammonia and H plus ion, ammonia that means central atom of nitrogen controlled everything. So nitrogen donates one lone pair for bonding. That lone pair, that pair of electrons is shared between ammonia and hydrogen. So therefore here you can see the arrow mark between nitrogen and hydrogen. This arrow mark is coordinate covalent bond. Here nitrogen is donor, that nitrogen is in ammonia, so nitrogen is donor and acceptor, hydrogen is acceptor. So this is ammoniate ion, NH4 plus. Next one, ammonia boron trifluoride. This is the best example for coordinate covalent bond. Here at the starting of the diagram you can see ammonia. At the central atom nitrogen, two dots are present. That two dots is the lone pair. With this lone pair, ammonia nitrogen has octet structure in outermost cell. So ammonia has already a stability. But look at the boron trifluoride. At the central atom boron, around boron only three covalent bonds are present. Each covalent bond has 2 electrons. That means boron has 6 electrons in the outermost cell. So boron needs 2 electrons to get stability. Therefore, when ammonia and boron trifluoride approach each other, then nitrogen donates that lone pair for bonding. That lone pair is shared between ammonia and boron trifluoride. Therefore, in ammonia nitrogen is donor and boron trifluoride, that means boron is acceptor. We always draw a coordinate covalent bond denoted by arrow mark from donor to acceptor. So you can see that the arrow mark is drawn from nitrogen to boron. That means nitrogen is a donor and boron is acceptor. So therefore in ammonia boron trifluoride there is a covalent bond. Next one. So general properties of ammonia compounds containing coordinate bond, showing higher melting and boiling points than pure covalent compounds, lower than the ionic compounds. And second point is soluble in organic solvents. And on the final point, they are poor conductors of electricity. So therefore that is the end of my presentation here. Thank you so much.